I'm Bill Maxwell. I'm at Obot AI. We build an open source MCP management platform. And over the next 20-25 minutes or so, we're going to talk about why agents and MCP are good and what MCP is and the basic primitives that you probably aren't aware of that make for an actual good development experience with MCP. So the reason we know coding agents are good, probably the best pattern for agents right now, the most successful anyway, right? We are definitely seeing value getting, making progress with these agents. And so they primarily work on code, and code is typically part of a larger process, your software development lifecycle. And so as you're trying to work with your code, it also would be nice to be able to work with your repositories, your issues, your tickets, pull requests, the pipeline, the build status, just really trying to understand kind of the end-to-end picture of what's going on in your software delivery lifecycle. And so the way you need to do that is you need the ability to connect to systems. And there's lots of different ways that you can connect to these systems. I mean, you have a coding agent, so you can just tell it, hey, connect to this system, here's some API keys, and have at it. And it could possibly write you a function for that. Tool calling, I think I heard, came out with OpenAI a long time ago now, and so you could do it that way. But really, you want a repeatable process and a way of interacting with these systems so that it becomes portable. You're not duplicating effort, or basically every time you switch coding agents or clients, that you have to rebuild this tooling and these systems, interactions with these other systems. And so that's where Model Context Protocol comes in. This is MCP, and it's really a system designed to connect your LLM models and your systems together so that you can interact with all of these different systems and capabilities. And so just really the way to think about it is that it's the USB-C port for these applications, for connecting AI applications to tools and data structures and other systems within your ecosystem. And so at a high level, there's really a few parts to the MCP ecosystem architecture that you're looking at. So you've got an MCP host, which is probably your AI application. That could be like a VS Code, it could be your Claude, it could be just a regular chat client. And within each of those, you define these client connections to your MCP servers. And so really, when you're interacting with MCP, it's these two pieces interacting together that really sort of bring out the whole experience. And so if you have a really great MCP server that doesn't have all of the capabilities, with a client that doesn't have all the capabilities to support all of the functions, then you're sort of in a weird space. So when we look at this, we're going to look at sort of the two sides of the MCP bits and where those primitives are. And so server side, you're looking primarily at tools, prompts, and resources. And so those capabilities are put into the MCP server as the developer of that server. And then on the client side, you have capabilities like sampling, elicitations, and routes. And so if your client supports these capabilities, you can now start to get a much better UX or experience, developer experience or user experience around the MCP kind of context that you're working with. And so each of these primitives really shapes how you're going to interact with these systems. So having a tool that just calls something that maps to an API may or may not be useful. These primitives give you the ability to get feedback, to interact with the confirm and actually have safety and actually have the ability to work with these tools and systems in a safe way, because agents and AI, the models, they don't always do the same thing twice. So you want to give it as much context and information as possible to make the right choice. So first, let's dive into tools. This is, I think, what most people believe MCP is. When you hear MCP server, you're thinking tool calls. I think on Twitter they fight that we can do tool calls 100 different ways. We don't need MCP. But really, this is the action surface and probably the most value-oriented piece of the MCP server that people really want, is they need that ability to be able to get information from something else and put it in to the context so they can continue working with it, build a presentation. And so these tools, as you're developing or evaluating an MCP server, you're really looking for clear tool names. You're looking for the descriptions to be accurate. You're looking for clear inputs so that you understand what's going to happen. So, for instance, this get GitHub issue takes an issue ID. It's very self-explanatory. It's like I'm conversing with you, which means the model has a better shot of actually understanding that tool and its purpose. And so, really, when you're evaluating or building the utility that you'll actually be able to get from it is largely dependent on how this is built. So if the tool name is ambiguous, like doesn't necessarily say like get GitHub issue, and you happen to have just get issue, and you're also using it with a Bitbucket or a GitLab MCP server, and sort of the same because your enterprise does everything, then you sort of end up in this thing. The model can get confused, right? Because if you say something casually, get this issue, it may or may not know which system you're actually talking about. And so you also want these tools to be somewhat focused on the intention piece. So I want to create an issue, right? I don't want to have to go get all the different pieces that I would need to actually create that issue on the back-end system, and being able to call with the different tools. And so, so looking at it a little bit higher level, a good design versus a bad design, we're going to focus on the intention of the user. So add note to contact, and it takes a contact name and the note. That's clear, the parameters are clear, it's mapping to exactly what I might want and casually say in the conversation. It's sticking with kind of that user-based language. In a bad design, and depending on which CRM system you've ever used, and you map things directly to an API, you have these different tools that are like get the contact ID, get the record, get the note. And depending on the model, or somewhere it needs to be instructed to do this, right? Like in order for the agent to actually succeed, either the model needs to know the CRM, and that's what it needs to do, which is unlikely if you're doing something with like a local model, and possibly even with the frontier models is not likely that it would be able to guess this. So then as a user, you're stuck prompting it and saying, okay, do this, do this, do this, which is not a great experience for you as an end user using these servers. And so, that is a bad design. The other thing, once we get past tools, the other capabilities that we have at our disposal building and evaluating MCP servers are prompts. Prompts are pre-built templates on the server side that give the user clues or actions to interact with the server and actually have a chance at succeeding in being able to get the agent to do what it wants, or just in a casual conversation. This is what gives people sort of the action and the ability to actually use these servers. And so when you're looking at this in Claude or different clients, you have these slash commands, and you'll see that they're like forms. And so, you have create issue, it's going to take like a title and a repository name, it'll figure that out for you. And so, again, it's the natural language way of interacting with, and as long as your tool names are good, like it should just kind of line up and have things succeed. The other one is resources. And so resources are pretty powerful and a cool capability. Yesterday I did a workshop on building a chess client or chess agent. And so with resources, we could actually use something called MCP UI and return HTML documents that then get rendered in the chat client. So then you can create these rich UX experiences with drag and drop chess pieces and the MCP servers managing the states in the background. But a resource in terms of MCP can be really any bit of data. These bits of data are not passed directly to the LLM. It's controlled by the user. And so the user decides whether or not they want to be able to pass that. Tools can create and return resources so you can get the record. So if I added a customer, I can get the customer record back as a resource. And so when you're looking at your client and how this impacts your experience as a developer interacting with this, you can see once you have resources, they're typically presented to you in like a file structure or a directory structure along those lines. It lets you select them and pass them to the model. And again, a lot of this is on the idea that you want to control and have some say in where your information is going, where your documents are going, and what's going back and forth between the model. Sorry. Next, sampling. So sampling is a weirdly named capability, but what this does is it enables the tool to request the client run an AI query. And so if you want to get a bunch of records and ask for a summary as part of the tool, it can do that. And what it does is it sends that back to the client, where the client then gets to decide, does this make sense? Do I want to run this? And so in an ideal situation, you would have a human in the loop that actually approves that request, that it says, yes, please do this. That you get to pick the model, maybe limit the tokens. But basically, again, giving back control to the end user through the client, but still having a mechanism to actually have the server leverage all the benefits of AI. So elicitations, again, some of these names, they're all low-level protocol type of names, but basically this is confirmations or ways to gather information from the end user. So a tool can confirm that you want to take an action. It can present like, hey, if you want to do this, I'm missing this bit of information. Instead of failing and going back out to the LLM, it can just prompt the user and say, hey, fill out this missing bit of information, and if you're ready, then we can confirm that that's what you want to have done, and actually go ahead and do it. And so, again, the practical side of it becomes sort of the, I say, delete a database. It says, without an elicitation, it says, okay, and it just deletes whatever database it happens to think you meant. With an elicitation, you could say delete a database. It could say, okay, I'm going to delete the production database. Are you sure? And then you can confirm or deny. So it builds this safety mechanism into the experience that becomes really pretty critical, I think, to good design of your MCP servers and tools. So as you're looking at different servers, you're going to definitely want to consider that. Routes. This one is basically the client. When it comes up, it can say, here's the directories to this. You have access to the server side, and the server can then, when it's referencing things, can say, I need to list directories or list files in this directory and make sure it's within that route. And so these are not a security enforcement boundary. These are just simply suggestions to the MCP server, to help scope and give the agent some context on where it's working and how that can look. Yeah. So again, in a nice client, it would auto-discover. It might ask you to provide this information, and so you can list different file paths, different directories, and then you can also confirm, like, do you want it to have access to /? No, I don't. But basically, this gives you a way to specify that. And so now if we can walk through sort of an example of how all of this kind of comes together, because there's a lot of different pieces. If you can think, like, I want to create the GitHub issue, right? You're going to hit the / command as the user, and that's going to pull up a list of prompts. And so there's a prompt that says, create issue in repo with the following description. And then you're going to submit that to the chat. The model's going to process that, and then it sees that it's got a tool that's available to create an issue. So it does that. The tool is well written, and you also notice that it didn't have a title field. And so based on the description that the user is given, it's going to send a sampling request to the LLM, to the client, and say, hey, generate a title for this issue, right? And so the user can either see that as a prompt or confirm, but basically now a title has been generated by the model and is now goes back to the tool, and then the tool says, okay, let's confirm with the user that this is what they meant and it's okay to actually create this. And so here they say, do you want to create this bug based on the title that was generated, and here's the repo. We'll just assume that the description is going to go in exactly as it was. And then the user confirms and says, yeah, and the tool creates the issue and the model simply responds, great, issue 1234 has been created in /repo. So that's how this is a good use case of how all the pieces can come together, more than just a simple tool call and a hope that it did the right thing. Yeah. So just coming back to it now, looking and picking a good MCP server, or if you're a developer of MCP servers and you're trying to figure out how do I make this MCP safe and build trust with my end users, then you're going to want to make sure that you go through and you have clearly defined tools. The name of the tool is probably one of the most important things in order to get the agent to successfully call it. If you ever get bored, give it random tool names with really great descriptions and it'll still get super confused. Again, you don't want your users staring at a blank screen, so you're going to want to have prompts. You're going to want to use elicitations. For any action that's going to have a side effect, you're going to want to make sure that they are able to basically confirm or deny that is what you want. You don't also necessarily, if it's been kind of a long conversation, you don't want to just have it fail out and have the user have to go back and enter all that information. So if you can elicit and say, hey, I need this last bit of data, can you please provide that to me? Again, that's what you're going to want to see or have available to you. If you are making use of roots, say you're working with source code, you don't want it to move beyond sort of the repository the Git repository directory you're already in, then you're going to want to make sure that's there. And again, when you're picking an MCP server, you're developing an MCP server, we didn't touch too much on this, but there's two types of protocols that an MCP server can typically interacts with. There's standard I/O, and these are typically run on your laptop, and so those are going to be given probably an API key if they're going to be running and communicating with remote systems. If you're going to do a streamable HTTP, that gives you the ability to host it centrally, set up OAuth so that people are logging in and you have centralized control over that. It's just a consideration on what you're using and how you're using them. On the client side, when you're using MCP servers, there's tons and tons of clients, there's different agents, there's different frameworks, but the things that you're going to want to make sure is that it does support the elicitations bits. You're going to want to make sure when you're using a client, if the server is asking you for a confirmation, that you're actually getting it and putting you in the loop. The sampling bits, if your MCP server is going to use it, it is a nice thing to have. Not all clients support this, but definitely you're going to want the ability to rate limit those requests. You're going to want to make sure that these things are... Whoa! Sorry. That surprised me. Right. Yeah, so... Yep. So then we didn't talk too much about the security side of thing. I kind of just assumed that we wanted the MCP servers. But with this, your MCP server potentially introduces new vectors, but you shouldn't forget your old school security and do the due diligence that you would for any other open source piece of software that you're going to run or consume. When you're selecting these MCP servers, you are going to want to typically use trusted third parties that have built this. If you can use the remote and it makes sense for you, then that makes sense. So, the GitHub host one remotely, Atlassian host one, just depending on the tool sets and if it's available. You're going to want to inspect all the tool names, parameters, and descriptions. You're basically looking to make sure it's not trying to inject something malicious into your code. It's a little bit time consuming. In the enterprise, if you are running MCP servers and you need to scale that out for your whole organization, you might consider using an MCP gateway like OBOT for audit logging and other things. There's other open source alternatives like MCP Jungle, for instance. You're going to want to scan your tool names and parameters continuously in case over time there's code that changes as things evolve. And you're going to want to centralize authentication. That's definitely something that becomes pretty important when you're scaling up consuming your MCP servers. And then filtering the ability to inspect and make sure that tool calls aren't taking data and sending that to different places that you don't want it to go. So thank you. If you've got questions, I'll be here for a bit and also at the OBOT booth.
Thank you so much. I feel a deep sense of shame. I've personally developed an MCP server, and now I feel absolutely terrible. I didn't see this talk beforehand. So this is wonderful. Thank you so much. I really appreciate it. Thank you.